Why do we multiply fractions such as 2/3 and 4/5 like? Multiply the numerators 2 times 4 and put the product 8 in the numerator of the product fraction, and then multiply the denominators 3 times 5 and put the product 15 in the denominator of the product fraction. To begin, I think of 2/3 times 4/5 as 2/3 of 4/5. This region model shows 2/3 of 4/5. First, we need to find 4/5 by looking at the columns. Here we have 5 columns, 1, 2, 3, 4, 5. And down here, we have 5 columns with 4 of them filled in. 1, 2, 3, 4. Now, for the 2/3, we need to look at the rows. So here we have 3 rows. 1, 2, 3. There are now 3 rows and 5 columns. Notice that the denominator for both fractions we are working with are both the columns and rows. That means the denominator represents how many pieces there are. Now going back to the numerator we filled in the first time, we will use those to find how many to fill for the 2/3. Now we are only looking at the part we already have filled in because the goal is to find 2/3 of 4/5. Earlier we established that the thirds are represented by rows, so that is how we will shade the 2/3. So here we have 2/3 of the 4/5 that are shaded in. Now that we have shaded the 2/3, we need to count how many of those are shaded. 1, 2, 3, 4, 5, 6, 7, 8. We know that the numerator is how many are shaded, so that is why you can multiply straight across the top to get 8, because 2 times 4 equals 8. So now the total number of pieces is the denominator, so now we need to go back to our original rectangle and we cannot ignore the unshaded pieces anymore. The total number of squares here is 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that is why you can multiply straight across the denominators to find your answer, because 3 times 5 equals 15, and that is the same as how many pieces we have here. This method will work for any proper fraction. So here we have found that 2/3 of 4/5 equals 8/15, or you can say it as 2/3 times 4/5 equals 8/15. I will now show you how this can work for any proper fraction with a generalized version of the table we previously did. So here we have A over B times C over D. This is the problem we will be working with now as a generalized version. So here is the model we will be working with. Previously, it was broken up based on the second denominator first, which in this case is D. So here we will break this up into D pieces. Then we broke it into pieces based on the first denominator, which in this case, as we can see here, is B. So here we will break this up into B pieces. We then begin to shade squares based on the numerator. In this case, the numerators are A and C. So here we break this up into C, and we break it up this way into A. So now, as we can see here, this whole part would be filled in. The filled in part is what we said the numerator was. So this now shows us that the filled in part was A times C. The denominator we discovered was how many pieces it was broken into, and that here is represented by D times B. So here we have gotten the answer, A times C over B times D. We have now discovered that when you multiply fractions, you can multiply straight across in any proper fraction to get the correct product.